I'm going to do a quick scroll through for example 4, which is going to cover while loops. In class, we'll go over things in more detail. Be ready to ask questions. Remember that example 4 is going to correlate with homework 4. And at the top of homework 4, there are going to be some videos, 2 videos, how to use math operators and while loops. So remember this video does not take the place of learning about while loops or math operators. It's just working through the example. All right, so the overview of a while loop. It's going to be very similar to an if statement, and that's where I like to kind of start. The difference is an if statement will run once when true, and then it leaves and it continues on with the code. Because our if statements are inside while loops normally, it seems like the if statement is running over and over again, but really the if statement runs one time, and the only way that it will run again is if it gets to that same spot in the code and is true again. A while loop is a little bit different. This is our next control structure. We go back up to example 2. We've been talking about selection structures for a while. That's our if statements and our else ifs and elses. We're going to get into our repetition structure now. I'm still going to have a condition, and if it's true, it's going to run that scope, but then what happens is it's going to check that condition again. And if that condition is true, it's going to run it again immediately. It doesn't have to finish and run through the entire code and then come back to run. It's going to run until it's false, and then it will continue on with the code. All right, so the setup for this problem is at least one digital or analog input and 2 LEDs. When I scrolled through here, when I wrote this, I had 2 LEDs and a button, and that's what the code in example 4, the one uploaded onto Google Drive, is. But we haven't done an example yet that has a photoresistor. And so as I work through this problem right now, I'm going to choose an analog input, and I'm going to choose the photoresistor. When we actually go through and we write the code, while one condition is true, and what is that condition? I don't know yet. I get to come up with that condition. We're going to blink both LEDs at the same time so that both are on at the same time, both are off at the same time. While the other condition is true, we're going to have the LEDs still blink, but they're going to alternate. One will be off, one will be on, and then the other way. So I've already made a circuit. Let's talk about this circuit really quick. I have my LEDs connected through the resistors and ground. And then I also have my photoresistor set up. If you don't remember how to set up a photoresistor, there's instructions to it on OneNote. You can Google it. In some of the other examples, we've talked about it. So this is how you set it up. We have 5 volts on one side. It goes through the sensor and down through the ground side. We take a reading after that 5 volts has gone through the sensor to see what's happening, how much voltage is left. And that's what we read at the analog input. And then before we bring it back to ground, we have to dissipate the rest of the voltage, whatever was not used up. And that's what this resistor is for here. All right, now as with the last example, I have already written some code in here. It's pretty simple. This would be my test code, just to make sure my circuit's running well. I'm gonna start the simulation really quick. My LEDs are both turning on. If this were built on the actual Arduino board, which I'm encouraging you to do, really all you'd have to do is with the photoresistor is you just have to change whatever light is shining on the top of this. You can do that by holding your hand over it just a little bit, get closer, block out more light. You could get the flashlight on your phone and shine it right on there. And that's going to change the light level. For Tinkercad, it gives us a little slide bar. So if we slide all the way to the left, we have this black circle, that would mean dark. And as I go to the right, we see that I have a white circle with these lines coming out. It kind of looks like the sun. It's showing that is light. Just to make sure this is working, let's open up the serial monitor. I'm getting a 54. That's on the low end. And as I slide up, you'll see that I've barely slidden up this slide at all, and I'm at 716. Remember, this is an analog sensor. My range goes from 0 to 1023. But yet, if I slide all the way down to the left, I'm at 54. And if I barely come up at all, I'm already about halfway up my numbers. What that means is when I get into this middle region, not a lot's going to change. Right, I'm at 800, 900, 917, 935, 947, 954, 963. And when I get all the way maxed out as bright as possible, if I could get the brightest thing shining on this that doesn't burn it up, I would get the reading of 974. Potentiometers are nice because you can really control the different pieces. You can say, you know, I can get 0, I can get 1023, I can get somewhere in the middle, I can control it real well. These photoresistors, they don't have a nice linear graph. You can't really say, I want to get 0. You can't say, I want to get the maximum. You have to test these out. And so this is a good test because I mentioned that while one condition is true, something's going to happen. While the other condition is true, something else is going to happen. So the reason I couldn't give you a full condition is because if you're using a button, the condition is going to be 0, 0, or 1. If you're using a potentiometer, you can control that really well and you can have kind of whatever range you want. If you are using a photoresistor, it's going to be really difficult. You might be coding this with your actual Arduino kit and you're in a room that's a little bit dark. It might be very difficult to get a value above 900 in your room. You might be in a spot that's really, really bright. It might be really difficult to get a value below 900. I don't know that. This is just a slide bar. It simplifies things. What you're going to have to do is wherever you're at, you're going to have to figure out, if I cover it up, what can I get? If I shine my flashlight on it, what can I get? And you're going to have to figure out what ranges are going to work. And so for me, I'm going to just pick this number kind of right here, somewhere in the middle, about 930 or so. And I'm going to make a little note down here. 930 is the middle value. What that's going to do for me is when I start having my conditions that I'm writing, I can say, all right, 930. If it's less than that, do this. If it's more than that, do something else. All right, first things first. I'm going to organize all this. I'm going to make some variables for my LEDs. Those have to be global variables because I use those LED variables in the void setup and the void loop. And so those variables have to be global so that both of those scopes can see it. So byte, LED, I'm just going to, we do LED a lot. I'm just going to call this red, byte red. And the red LED is connected to 10. And then I'm going to have byte blue just with 3 letters. That way both of them have 3 letters, and that one is connected to 9. You can call them whatever you want. I'm, again, just mixing things up a little bit, showing you that there are options. All right, we don't have to do a pin mode for the photoresistor. The reason for that is because pin modes are for digital pins. And the photoresistor is connected to the analog side of the board, so no pin mode is needed. I'm going to go ahead and I'm going to get rid of everything I have so far, and I'm going to kind of start over. I'm going to get a variable for the location of my photoresistor. So byte photo equals 0. So now when I want to say read the photoresistor, I don't have to remember that it's pin 0. I can just type the word photo in and it's going to read the photoresistor. I'm going to do that by making another variable. I'm going to make this an unsigned int. I haven't used this yet in example, I don't think. We use ints data type in int data type, and what that's going to do is it holds a larger value than a byte does. What unsigned does is it makes it so that we can't hold any negative values. And why am I doing that here? I'm just showing you options. For this example, it's perfectly okay to use an int type. It's okay if we are allowed to store some negative values. We won't be storing negative values, but it's okay that we're allowed to. Value equals analog read, and I'm going to analog read photo. So again, what's happening? We say that we want to analog read a pin. We want to take a reading of what's happening at this analog pin. Which pin? Pin photo, which equals 0. So it's going to look there and it's going to see what's happening. There's a number coming out of there between 0 and 1023. That value is going to be stored into our variable called value. Now, what I want to do really quick is let's pretend that this was an if statement. Let's pretend that this was example 2 or example 3, and I want to use an if statement here. I would do something like if value is less than or equal to 930. Remember, that was my middle point. Sometimes we call that our threshold. And so if I get below that, something's going to happen. If I get above that, something else will happen. All right, so I could have this if statement. And if I were to think about it, what would be happening here is we take a reading, something gets saved in value, and we come here to our if statement, and we see if this is true. If it's true, we come into this if statement, we run it once, and then we leave. And so I guess long story short, if statements automatically have an exit condition. The exit condition is if we ran once, we're allowed to leave. I'm going to turn this if statement into a while loop using 3 steps. These steps are covered in all the videos about while loops. The 3 steps are simply, I'm going to change the word if to while. Second, I need to update my method of getting in or out of this while loop. I need to update this condition somehow. I'm going to do that by taking the exact same way that I got in, which was line 16, right? Line 16 was the line that was read that saved the value, which allowed me to get in. I'm going to take that entire line, I'm going to copy it, and I'm going to paste it inside of my while loop scope. That's step 2. And step 3 is I get rid of the data type. That's it. Now I have a while loop. Now, let me tell you real quick why we did that, and then we'll go ahead and we can add some stuff to this. Because a while loop can run repeatedly, it also needs an exit condition. Let me get rid of the exit condition for now. I'm allowed to get into it because on line 16, I have a way to get into the while loop. So if I get into this while loop because value is less than or equal to 930, then I'm going to come in here and it's just going to keep reading this. It's going to run this. Sorry, it's not going to read it. It's going to run this once. It's going to come back up and it's going to check this condition again. Is value still less than or equal to 930? Yes, it is. And it's going to run it over and over again. The problem here is if these are the only lines that are running, lines 20 through 23, how is my variable value ever going to change? And the answer is it can't, because what's highlighted here is the only code that is running. I never get back to line 16, which means I can never update my value. That's why we need to make sure that we're updating that condition or the ability for that condition to change within the while loop. Now, since these are the only things that are running, we have a way to get in, and once we get in, we can continually update this variable so that we can actually get out at some point. Value is updating, which means that we're allowed to leave. Now, we had unsigned int in here before, and I said we have to get rid of that. If I keep the data type here, then my code won't run properly. And the reason for that is anytime you write something like unsigned int, or you write something like byte, it makes something in memory. That's the whole point. On line 16, I would be making a spot in memory called value, and that value variable is within the loop scope. The way I have it written, when I get to line 22, it would make a new spot in memory called value. So now we'd have two spots in memory called value, one for the loop scope, one for the while scope. We would be assuming that it would be checking this new value, but we'd be wrong. The computer or the Arduino would be checking the original value. To make it so that it's not confusing, so that we don't have two variables called value floating around and not knowing which one's which, what we want to do is we want to make sure that we're not making a new variable called value. Instead, we're just updating the old one. And I update that with the assignment operator and my analog read function. All it's going to do is it's going to overwrite what used to be in value. We're not making a new spot called value. All right, so a couple things real quick. I'm going to do this one more time. This time I'm going to do it in 2 steps. Last time I showed you how to change an if statement into a while loop in 3 steps. I'm going to do it in 2 steps this time. First step, change the word if to while. Second, I'm going to take the method that I am going to be updating this condition. That's line 16. I'm going to copy that entire thing except for the data type. And I'm going to paste it inside my while loop. I combined those last 2 things this second time through. So one way is you can take that whole line and then delete the data type, or I can just copy and paste everything but the data type. But what this does now is I have a way to get in, I have a way to get out. I get in because line 16 updates something before the while loop. I can get out because while the while loop is running, I can update that variable and eventually get out. All right, I want 2 while loops, one with one condition, one with the other. I'm just going to go ahead and flip that sign so that it's the opposite. Now, technically, I probably don't need to have this second while loop because the while loop will run and stay here. And when it's false, it will leave. And basically everything else is the opposite. But I could very easily make this second while loop. Let's go ahead and just stick with this one for now, though. Okay. All right. So I have this threshold of 930. I'm going to go ahead and move this comment right there. All right, now what did I say we'd want to do? While one condition's true, we want the 2 LEDs to blink at the same time. So now that we're in here, digital, right, red, high. I'm just going to do a little bit of copying and pasting to make this a little bit easier. I'm going to turn both on. I'm going to delay for a short amount of time. I'm going to do 300 milliseconds. It's going to blink somewhat quickly. And then I'm going to do the exact same thing except for turn them off. So instead of high, we'll do low. Now, I haven't tested this out recently. I probably should have been testing it out a little bit more. There might be some errors. The more that you type, the more likelihood there will be some type of error. So let's go ahead and run it and see what happens. See, we do have an error. Line 4, what did I do? I forgot the semicolon. Happens to everybody. All right. All right, so it's blinking fast. Should it be blinking right now? Well, we're inside the while loop. That's the only place that it could be because we're blinking. And that means that this condition must be true. That value is less than or equal to 930. Let's open up the serial monitor. We are getting 935. It's not quite what we were expecting. Let's clear this and I'll let you know why things aren't working quite right. So what's going to happen is, number one, I don't have any serial prints in here right now. I have a serial.begin, but I'm not printing anything. All that stuff before was during that test code. So let's run this again. It's blinking. I have no idea what's happening though. So what I want to do is I want to do a serial.println of value. Let's see what happens. All right, so it prints the number 54. That was the value on the low end. It's blinking, but nothing else is printing. And you might say, why isn't it printing? Well, let's look at where we're at in the code. We're inside this while loop. Let's look at each line. Am I telling it to print on line 21? Nope, just taking a reading. Am I printing anywhere else? No, I'm just doing things. So if I want it to print while I'm inside the while loop, I need to include it in there as well. Right now it's printing outside the while loop. I want it to print inside as well. Got to be careful with while loops. Anytime we want something to happen while we're in there, we have to make sure that code is inside of there. So now it's printing while it's inside this while loop, because when it gets to line 22, it prints the value. So that means it's updating, not only updating, but it's showing me what it's updated to every single time. If I get above 930, we should stop blinking. And if I get back down, it should start blinking again. All right, so we're halfway there. We have, while one condition is true, blink both LEDs at the same time. While the other condition is true, have both LEDs blink, but alternating, one off and one on. All right, so I said we could do one of two things. I could have another while loop with the opposite condition of this, and we could get into that one. Or what we can do is we could say, you know what, let's just take and write what we want to have happen outside of the other while loop. Let me clean up the code a little bit. It's nice to keep the code a little bit organized. All right, and so inside the while loop, we have blink together. And outside the while loop, we have blink apart. I got to make a couple changes since I copied and pasted. All right, so there we go. Let's talk this out real quick. I have a while loop. I have a way to get into it. I print that value so I can see it. When I get into it, I have a reading again so that I can get out. I print it so I can see what's happening. And then I do what I want it to do. They're blinking together. This is going to happen over and over while this condition's true. When this condition's false, we're going to hop out of this and we're going to blink them alternating. We're going to come back up here. It's going to take another reading. It's going to print that reading. And if this is still false, it's going to hop over it and it's going to blink them alternating. And it's going to keep doing that until this while loop is true, which means it jumps back into here. So it might take a bit to kind of read through this and see what's happening, but let's go ahead and see what happens. So right now they're blinking together. They're blinking together because we're less than or equal to 930. I get larger and they're blinking alternating. I'm above 930, I'm at 960. I can get up to 974. I can do 969, 963. They're alternating because they're all above 930. And if I go back down below, they're going to start blinking together. Now I know these are working different than an if statement, because if I were to have this be an if statement, you'd see that it blinks together and then they blink alternating. This if statement would have them blink together. And because an if statement, it only runs once, it would leave and it would blink apart. And then it would come back up here and they would blink together and then blink apart. It kind of makes it a mess. And so that's how we know that the while loop is working a little bit differently. Because it's either holding in one scope together, or it's staying outside of that scope. And in this case, that would be blinking apart or blinking separately.